Good morning, good afternoon, good evening. It is another very exciting episode of the LMTV WTF Live. WTF as in, where is Tony Fortunato? So why not let Tony tell us where he is today? Tony, are you at home again?
Yes, it's a rare occurrence. I'm at home again.
Now, pretty soon I'm going to get an email from your wife that just said, oh, we should do this show every day, right?
The exact opposite.
That way we get to see Tony at home all the time. Yeah.
That's
Hey
right.
Tim, how are you?
Hello. How's everybody today?
You gonna last the show today?
Yep.
Okay.
Then I'm
Wow.
gonna crash.
Yeah. So yeah, I know. You're a performer. When the spotlight is on you, you will survive, right?
I'm a survivor.
Survive.
So Tony, this is a live show, and we do have live audience. So just so you know, for those who are watching us live, you can ask questions, and if you're on the event page, just move your mouse to the left edge, find the icon that says Q&A, click on that. It opens a panel on the right and start asking questions or just comments, even nasty ones. And if you're watching it through the YouTube, I believe there is a icon that looks like a quote, open quote, and I think if you click on that, it will bring you to the event page. I think. I'm not sure. I will try it. So with that, Tony, take it away.
All right, folks. So today's session, we're going to do something a little different. I talked to a few people about doing a baselining session, and that's what we're going to do today. We talk about baselining. Just want to put a few words out there so you can think about a couple of things. Number one, baselining is obviously going to be different depending on what you're trying to accomplish, and that's all in the actual presentation. So the goal of this one, just so everybody's on the same page, is to talk a little bit about baselining, the framework of baselining, how to get started, some of the things I look for, some of the things I do. I'm going to give you a couple of things that you could even do today, right after this session, as a quick example of a baseline. So this isn't an all-encompassing course, of course. But this is from my throughput and latency class that I typically do on-site for customers, and I've just taken a few slides out so that way you'll have a couple of slides to look at. So let me just go to screen share. There we go. And now, there you go. So this is the throughput and latency class, as I said earlier. Let me just get rid of this. And I'm going to start from the beginning. So why baseline? Well, as I always say to people, I'm surprised how many times I see people instructed to create a baseline with no real purpose or goal in mind. And I've even heard people use terms like, sniff, or go sniff that, or go Wireshark that, or go capture some packets, but they don't even know why they're doing it. This makes your job extremely difficult, and basically it turns it into one of those never-ending requests that you just never seem to end, because guess what? You never had a target, you never had a goal. So here's some examples of why you may want to create a baseline. So there's always, this is what I usually do, this is my number one reason, an educational exercise. I want to learn more about the application, I want to learn about the protocol, I want to learn about IPv6, I want to find out why it's doing what it does. Second point, I want to understand how the application behaves for future reference or tuning. So if I've seen an application run in my office and then I duplicate and replicate some issues and then I go out in the field, guess what? I got a really good idea of what the problem is because I've seen it before. So that gives you a lot of, I call it, tribal knowledge. You can also use it to measure application performance to properly predict network requirements. You can use it to document the impact of a network or application change, and I can't tell you how many times my regular customers now call me and say, Tony, application X is going to have an upgrade next month, and we want to make sure that everything's going to work well, better, or not worse. So we talk about those application profiles or comparisons that we do. You can use it to create an effective troubleshooting methodology, and that's pretty cool because once you realize how an application behaves, not that there's a shortcut, but you'll know what things you don't have to worry about. In one of my TCP/IP classes, I go through the entire packet line by line, and I preface every line with, you don't need to know this, you don't need to know this, and this is when you need to know this. And people find that kind of thing quite helpful. And the last point, to determine application behavior to properly configure network equipment. And I got a little bit of a security slant on this. Simple things like firewalls or Cisco ACLs. If you don't know what protocols these applications are using, you can't properly filter these things. If you do get an alert on a firewall or some kind of intrusion detection, there may be a reference to a port number. Again, if you don't know what these are, you're kind of behind the 8 ball. So do not proceed without a clear goal or target. And I say the same thing about general tool use. So if you do have your favorite tool, you don't just pick it up, plug it in just because. You want to do something with that. A good methodology or a good analogy I give people is I've got a garage full of power tools and they're not running right now just because. I'm going to go grab them when I need them. Here's a little bandwidth exercise everybody can do. And this is real simple. So you just go get a file and you copy a file to and from your server and basically record how long this takes. So all you really need to do is have a stopwatch, a watch, smartphone, whatever application that's got a stopwatch on it, or just eyeball the clock. Copy this file, and these examples, 12 megabyte file on a 10 megabit Ethernet, 120 megabyte file on 100 meg Ethernet, and 1.2 gig on a gig Ethernet. And the reason why I gave those specific examples, and these are ballparks, of course, when you do the math, this should take approximately 10 seconds, theoretically. Anybody in their right mind knows this will not take 10 seconds. This is probably going to take longer. Further to this exercise, I'll kind of give you a little bit of the ending now. When you do this over a network, I always ask people, well, try it locally on your hard drive. Just copy a file, see how long it takes. It'll take 10 seconds. And sometimes the 1.2 gig file takes 30, 40 seconds on your hard drive internally. Forget the network. So how do you expect it to go faster when you plug in your Ethernet cable? So this is a very, and I say this is a very obvious example of using some basic math. No protocol analyzers, no SFlow, SNMP, no probes, no nothing, just basic math. So theoretically, all these scenarios should take about 10 seconds, and how did you do? Now, what if it took you 11? Is it the end of the world? Are you going to go check all your wires and your configs? Versus 55 seconds. So you need to figure out in your own brain, 10 seconds is theoretical, but what am I willing to deal with? What's my threshold? The basic formula for all these numbers is simple. Just take the number of bits, like 10 megabit Ethernet or 100 megabit Ethernet, divide by 8, and multiply by 10 seconds. And that's how I got the magic numbers. Okay? So if you didn't have a 1.2 gig file and it was 1.35 gig, that's fine, you know, just more or less, just so you have a way of figuring it out. So the other question is, how else would you measure the network load you created during this test? Would you use SNMP from your switch? Would you span or mirror a port with a protocol analyzer? Would you have some kind of other tester connected to it to monitor this? Would you use Microsoft's perfmon, or if you use Linux or Android, would you use their utilities? You need a way to find out how to consistently measure this stuff. There is no wrong answer. That's the best part. The only answer is the one you have. So if you only have a protocol analyzer, knock yourself out. If you're an SNMP guru, fantastic. As long as you have a way to measure this and you can replicate it, you're doing the right thing. Does it matter if the server is local or remote? Well, of course it does, because a local server should be faster than a remote server. And that's a great comparison, because in some companies they have the same platform locally and remotely. And if you do the test and you find out the remote takes 30 times longer, chances are that's that network latency, that distance latency. All that kind of stuff is adding on to your total time. What about protocols? So what about Microsoft versus HTTP versus FTP, all that kind of stuff? What about LAN versus Wi-Fi? And that's a big thing, because most people with Wi-Fi now are expecting LAN or wired type performance. And of course, it doesn't work like that. For the people old enough, when Wi-Fi first came out, you know what they called it? They called it wireless Ethernet, which is completely erroneous. And that guy hopefully has a job doing something else with his life, because that was crazy. What about disks versus RAM? So if you copy this stuff across a network, are you using your disk to copy these, or are you running all your tests within RAM? Of course, disks are slower than RAM, generally speaking, so that would have a dramatic impact on your results as well. So there's your little pencil. You can take your analog recording device and go get some paper, and you can do this anytime you want. So, common baselines. So baselining is often a forgotten art. Most people don't baseline for the following reasons. Well, here's the excuses I hear. Of course, the list is much longer, but this is just a short list. When should I start? People are always waiting for an excuse or an opportunity to start a baseline. What should the baseline look like? Well, you know what? I'll give you some answers. How's that? When should I start? How about right now? What should a baseline look like? Any way you want. A baseline, I tell people, by definition, is a snapshot. It's a recording. It's a number. It's a time. It's whatever you want to make it. So in that previous example, if it took me 30 seconds to copy a file using Microsoft's Internet Explorer from a web server, that's how long it took, and that's my baseline, period. You don't like it? Go fix it. But now you have a number to compare it against, not an opinion. What if someone actually reads it and wants more information? Oh no, now what? And this is honestly, this is one of the biggest deterrents that people have against baselining or reporting in general. They're always worried that somebody's going to read it and want more information. I look forward to that, because if I forgot something or overlooked something that should be involved or included in that baseline, tell me. I don't want to make the same mistake again. It's all about learning, right? Why bother? Everything changes so fast around here, and that's the best thing, right? People are always like, hey, everything's always changing. By the time I finish the baseline, everything's changed. I tell people, by the time you finished complaining about it, you would have had a baseline, and that's, you know, quite literally the truth.
Hey,
and the last one is, I don't know how to baseline. And basically, when I hear people say they don't know how to baseline, I always say, great, neither do I, because every baseline is going to be different for every application, for every location, and every tool. So my regular customers now are accustomed to hearing me say, I don't know, let's find out. And there's nothing wrong with that, because the guy with all the answers usually doesn't have one. Baselines, they should be clearly defined. Real simple. Just like I said a moment ago, you copy that file and you time it. Done. There's no other way of doing that. For example, some examples of some baselines, if you've ever actually thought up some. These are some of my more common ones. A PC boot up baseline, we just turn on a computer and you record everything it spits out onto the wire. A login baseline, so you can see how authentication servers and protocols and DNS and all that nonsense kicks in. Application login baseline, so you pick your favorite app and you just simply log in. Don't do anything else, just log in. And what I try to do is I try to pick one thing, one task to baseline. And the reason why I pick one thing is it's easier to compare later on when somebody says, my application is slow. And I said, well, everything? And when you get right down to it, no. There's usually specific tasks that are affected. For example, logging in is slow, or the query is slow, that sort of thing. And if you had isolated that earlier, then guess what? It's easy to compare instead of gathering 4 gigabytes of data and trying to vet through that. Throughput baseline is pretty well what we were just talking about a little while ago. And then network upgrade baselines. And I've done a lot of these where people will say, I'm going to get a brand new switch or a brand new router to improve overall network performance. And my simple question is, well, what is it now? And they don't know. But the new stuff is newer, and therefore it should be better. And I've actually done a lot of these where the newer stuff actually makes the performance worse. So you better arm yourself with some data. As long as your goal is clear and the methodology is documented, your baseline is correct. There you go. You can take that and frame it, and it's always right. Okay, you can show that to your boss. If you perform the baseline correctly, you will typically find problems to fix along the way or settings to tune. Face it, we're IT people. We're going to go muck with something. So it's kind of helpful if you think you know what you're going to change, but you have a number to compare it to when you have a result. And I can't tell you how many IT people will blindly change something because they heard it's a good thing to do, but then when we measure the impact, it's far worse, and they should have left that alone. So your baselining options. Well, the first step to a successful baseline is determine what you want to baseline. So again, some more examples for you. The network. People like doing network baselines or network health checks. And those examples, you're going to record things like load on the network or bandwidth utilization, all the same thing. Protocol distribution. What kind of protocols are flying around my network? IPv6, IPX. I was on a network last week where there's still IPX rampant on their network, just because it's always been there, just through evolution. And then, of course, other network characteristics. Then you've got things like specific network equipment, where you might want to log things like temperature, port errors, logs, things like firewalls. You want to make sure that the stuff is behaving as advertised, that sort of thing. Workstations. You might want to document things such as protocols, the application dependencies, and that dependency point right there, that might be a whole other session, because I'm surprised how many people, when you point this out to them, they realize they've overlooked something. To make an application work, many times there are other servers and protocols involved that make it work. But more importantly, if those things don't work well, then the app looks like it doesn't work well. Simple example, you go to the internet, you're actually relying on DNS to make that work for you. If DNS is down or the path to DNS is down, it's obvious you can't get the web page. But if the path to DNS is congested, then the internet seems slow. And that's an example of an application dependency. So we may do a separate one on that altogether. Measurement, point, and methodology must be documented so you can properly duplicate your tests or retest. And that's incredibly important. Then we talk about something called synthetic transaction performances. So what are we talking about here? Well, several products on the market can do something called a synthetic transaction. So you basically say, pretend to be a web server, pretend to be an SQL or an FTP or whatever server, and it runs tests across the network for you, and it will return packet loss, throughput, latency, all that good stuff for you. Little caveat, the results are only as accurate as a synthetic transaction is, or the code is, and those test computers are. So it's kind of important to realize that you're only as good as those two variables. In some cases, the good news is you can simulate multiple workstations with just one. So you can say, hey, what if 30 people ran this SQL query across the WAN? What would that look like? And that sort of thing. The accuracy of the synthetic transaction versus performing the same transaction live, for example, comes into question, since these test nodes may not properly represent the production node specifications or load. And all that means in English is when you make believe, well, you can't possibly factor in things such as network load or server load or latency. So those results may be skewed a bit and make life look a little too rosy. Ensure that these tests are not executed solely from RAM, and that's the problem with some of these synthetic transaction apps. They are so small that they run in RAM, and again, that will skew things because the time it takes to go to your disk, and there's your read time, your seek time, your write time, like those times add up to latency, and you want to make sure that you factor that in. Of course, there's the big old auto button there that people like to hit. All right. Protocol analyzer. So the data is gathered using your existing traffic, and this is obviously my preferred way to do it. The results are really what is happening on the wire. It doesn't require the introduction of any additional traffic. It's basically you're getting the person to do what they normally do. It takes into account production server, client loads, network configuration, and any other quote-unquote undocumented variables. So you don't need to make stuff up. Just ask the customer to do what they normally do, and you basically capture those packets. The analysis points must be selected carefully to provide these accurate results. And we'll talk about your placement on the network in just a few more minutes. This approach is the most labor-intensive. I'm not going to kid you. This takes a lot of time and requires a high level of protocol analysis understanding. Now, here's the good news. The first time you do any of these, I don't care what tool you use, it's going to take a long time because you've never done it before. And you're going to bang your head on the wall, and you're going to get confused, you're going to get frustrated. And the second time, there's going to be less lumps on your head, and it's going to go quicker. And by the third or fourth time, this is going to be done in a few minutes. Try to produce reports from your trace files to better explain and understand your findings. So most people don't want to see your packets. I tell analysts, pretend the packets are your vacation photos. Nobody cares. So just tell people what happened graphically. Use some kind of graph. Use a pretty picture. Make people happy. And of course, that's what you don't want to show them. So here's a network configuration example. We've got a client over here, and we've got a server over here. And of course, we've got different kinds of switches, and they're all connected any which way. So where would you go for your capture packets? Where would you start capturing packets? Now, every single answer could be correct. And there, that kind of ruins it, doesn't it? But realistically, what I always like to do is start near the client. And the reason why I like to start near the client is very, very obvious. They're experiencing the issue. So why not get their perspective of things? So whatever you capture at that time, if the client behind you says, yeah, this is awful, guess what? All those packets equal awful. There you go. It's that simple. So if the guy behind you says everything was great, that run was fantastic, that was super fast, well, now you've got a super fast baseline. And that is one of the things that people try to, a little hurdle they try to throw in front of themselves that they don't need to. People will say, I don't know what fast is, I don't know what normal is, and I don't know what slow is because I've never captured these packets before. And I say, right, that's why you use the human behind you for that opinion, right? So a quick review. There is no single correct means of measuring network performance. Not only must the proper tool be selected for the job, but the proper methodology must be used along with that tool. In some cases, you may want to try to document in what direction is the main source of latency. This is a very key point. When I'm on a complicated network, people are asking me, where's the problem? Is it the server? Is it the switch? Is it the router? And people make a big mistake. You'll capture some packets, and it'll look like they are the source of latency. Please be careful. Unless you're physically near that device, you don't know. All you can say is it's in that direction. It's towards the WAN. It's towards the server farm or the data center, that sort of thing, okay? Don't shoot yourself in the foot. Document your methodology as well as your findings. And this is where I trip everybody up all the time. They'll show me a report, and I'll say, great, how'd you do it? And then the truth comes out. I didn't do it. We had a consultant do it. Or Larry did it, and he doesn't work here anymore. So if I can't reproduce what they did, then the results are less important to me because I can't reproduce it. Always remeasure after any changes. And one of the rules I use in the field all the time is always record the impact of a change, one change. So one change at one time. Don't make 40 changes and say, oh, look, that worked. Well, chances are one of those 40 things actually made a difference, not 40. In many cases, you should take more than one measurement. So what I usually do in the field, if I can, I'll take 5 measurements or trace files. I'll drop the highest value, I'll drop the lowest value, and I'll average the 3 remaining values, okay? Because sometimes that first one might have been super fast or super slow, and you don't want to run away thinking that was the case. Automating or documenting these tasks will ensure each task is performed identically. So where do you start? Well, when you baseline or troubleshoot, you typically, as I said, I always like to start near the client. Well, in this case, it's quite common for a help desk person to ping a server with the application that a client may be complaining about. So my email is slow. So the help desk guy pings the email server. Well, is the ping the same as running email, like an email app? Of course not. They're totally different protocols. In some networks, a ping may get rerouted or it may get blocked, and that sort of thing. So you always have to keep in mind what you're trying to test. Ping is a great way to find out if something is down or if you have a severe latency issue, but typically if it's running and slow, ping doesn't typically do much for you. So do you dismiss the issue as a local issue since no one else has complained yet? And that's the other thing too. I hear this all the time at the help desk. Nobody else is complaining. It must be Mary. And then they do the personal slant. It's her again. She's always calling the help desk, you know, and they try to dismiss the issue. Do you start troubleshooting near the server, on the backbone, or near the client? And as I said earlier, spoiler alert, I always start near the client. I typically start investigating problems in baseline from the client's perspective, and that's typically my start point. But when you talk about application analysis and what steps are involved, we're going to baseline the application. And that involves a bunch of stuff, including reviewing trace files. If required, some people may ask you to predict the application performance. I love that because it's very difficult to do, if properly at all, actually. Measure and compare the application performance in production. And that's kind of a separate point that, again, may be a whole other session. Troubleshoot the application if necessary. I cannot tell you how many times we baseline an application and errors out of the yin-yang are constantly coming up on the trace, but the application works. So I'm the guy saying, well, why don't we just fix that stuff? It'll only run better, right? And more importantly, I try to explain to the technical staff, if those errors were there and we had an outage or a problem right now, you would think that would have something to do with it, where they may have always been there, right? So baselining the application, the purpose of this step is to collect all the traffic that crosses the network from the start of the application to the end of the application. And I'll give you a clearer example of that. So this traffic is going to be divided up into individual tasks for analysis. So it's imperative that every step and the exact configuration and location of all the equipment is documented properly. Now that sounds overwhelming, but it's not that bad. This step directly impacts the remaining process, so be thorough. Okay? So here's some simple little things you may want to keep in mind when you document your baseline. So the segment name, is there a VLAN, the voice VLAN, the data VLAN, that sort of thing. Switch identifier, is there a name for the switch, an IP address? If the switch is multiple chassis, then you may want to identify the first one, the second stack, all that sort of stuff. Note if you have mirror ports, if you're using a hub, are you using a tap, right? How are you getting this information? The date and the time. This one came into, this one was a big one for this last baseline I did in December for a customer. They wanted to do their baselines on a Sunday. And I said, why would you do that? Because there's no load. And they said, well, it's the only time we have time to do it. I said, well, you can do it, but please put a note that it was not production time, right? Because that's obviously going to affect things. You want the source station IP, the MAC address, any protocols that may be loaded on it, or protocols you believe are loaded on it. Now there's a lot of applications that bring their own protocols along for the ride, by the way. Operating system and application version. Little things, just little points, like these are all points. These aren't pages and pages of documentation. And then a script of what the operator will do in detail. Excuse me. Screenshots are optimal. Please be careful. Do not do a screenshot of something that's going to be some sensitive information or account information. Just use some common sense if you can. Data collection and intercept options. So capturing the data can be done many different ways. But again, the methodology and tool must be documented. So you can use the following methods to create a baseline. So we can use things like NetFlow, SFlow. Well, geez, even Armon falls into that camp, I guess. You can use SNMP, why not? Server or PC specific stats. You can use perfmon, you can use netstat, you can use all sorts of commands now to document stuff. Packet capture, and this is now it starts to get a little dicey. If you're going to capture some packets, you might have software installed on a server or a client. You may have software on some device along the way, right? So make sure you document that stuff. That all matters. Then you have packet intercept options. You can span. Tim is rolling over right now. You can span or use similar commands. I still use hubs a lot, and I'll give you a good example of why I use hubs because they're still very helpful. And of course, you've got a good old tap, and there's my tap right there. Okay, so we've got capturing the application traffic, and here's a hub example. So we set up an analyzer to capture all the traffic to and from the test workstation. And the hub configuration is only applicable and helpful if you have half duplex configurations or when you just want to observe the application behavior. This is key, behavior. So I just want to find out how it behaves. I don't care about the performance right now. I just want to see who it's talking to, how many packets, what protocols, and that sort of thing. So obviously a full duplex configuration would require a full duplex tap or mirror or span port as well. I don't want to get on this too much because this is a whole other topic, but spanning, please just span what you need to do bare minimum. Please don't span VLANs or like don't get carried away, right? Just pick a port. And when somebody says they don't know the port, I say find out. Don't just say I'm going to do the whole VLAN to get one guy. Don't do that because you're looking for trouble. Okay, filter on specific and relevant data. So set up a filter to capture all the traffic to and from the MAC address of the workstation. So why the MAC? And this is a big conversation in itself. I always start with the MAC address for one basic reason. I never believe which protocol the customer says they use. And nothing against them. They just may believe, I'm using that word carefully, they may believe they're using IPv4 or IPv6 or whatever they're using. But at the end of the day, they don't know. That's why they believe. So I'm going to use the MAC filter first. I'm going to find out what it really is, which may end up being a whole other example of what we do on site. But at the end of the day, if they said it was IPv4 and it is, good. There's nothing wrong with that. We've confirmed and validated what they thought. Life is good. right? No fist fight required. This is all good, right? So creating a script. And this saves my bacon every job, and I'm sure even Paul is going to attest to this. So you're going to create a worksheet that outlines a script of tasks to be performed, and this will ensure consistency. That's all it's meant to do. You're going to provide columns for the starting and ending frame numbers. So if you don't know where that is, even on Wireshark at the bottom here in your status bar, it says packets, in this example 181, and you can just glance at that if you like, and that way you know packet 181 I logged in. Packet 500, I made a query. And then that's just very simply put. That's all it is, okay? And there's an example of a simple script where you launch the application, in this case via the icon, enter the login name, Joe Smith, enter the password. Please don't write that down in your documentation. Don't put people's passwords in there. And select the account query from the main screen, and then query to account 123. I can't tell you, and actually I have a job tomorrow where this is going to come in handy. I start working with somebody and I come back for them to test again, and guess what? They went to lunch, or they left early, or they don't work there anymore. They just got fired that day. Lucky me. So when I ask somebody else to test the application, they have no idea what they tested. They don't know what login name they used, password, was it development, was it production, what account they used, because every account's slightly different, blah, 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 blah. So this will help me make sure that test is consistent. So the other thing we're going to do is before each task is performed, note the frame number, as I just said. So I've just written that down for you. After the task is complete, we note the frame number, just as I said. Well, this is something that I haven't said yet, which is a little trick I use. And I create something called a packet bookmark. And what I do is something that has nothing to do with the application. For example, ping. So on the customer screen, I'll make a little shortcut, ping google.com, for example. And they'll log in, and I'll say, could you just click the thing that said google.com, and they'll hit that, and a couple of pings will go out, and I said, okay, go ahead, proceed. And that way, in my trace file, I'll see these pings, and I can just simply write down logged in, pinged, query, pinged, and that's my notes. Later on, when I look in the trace file, like 10,000 or 100,000 or a million packets, I'll have a better idea of where that is without having to constantly look at the packet counter, because sometimes it doesn't stop, it just keeps going, right? Then we repeat this process for all items on the script. Make sure the person running the application waits for your signal before they move on to the next task. This is the biggest problem with baselining, is the carbon interface between the seat and the keyboard. People will take things differently. Some people will say, oh, you want me to run the application? That means they'll launch the app, they'll log in, and they'll do a query, and they'll look at you and say, now what? And you hadn't even started your analyzer yet. So just make sure, I tell people, just treat people like your children. Just say, hold on a second, please. Just wait, and then walk them through it 2 or 3 times, and they'll get the hang of it. So just don't assume they'll do it the way you want to do it. After the testing is complete, you go through the capture file with your little worksheet. Try to resist the impulse to start analyzing data, since it will distract you. IT people are distracted by shiny objects and packets. So please make sure they do not become distracted. So there's an example of that same script, and we've just put some frame numbers around that. Many times these frame numbers will look obvious in a graph. You'll see a swell of data, and then it's quiet for a bit because you've asked the customer to wait before they've inputted something. So these frame numbers don't have to be exact, but they'll be fairly obvious when you need to review it. Now reporting your results. So now that you've gathered and calculated the traffic per task, prepare a chart with your findings. The only other variable to include is how many clients will be or maybe were using the application. I get a little, not annoyed, but I get a little frustrated sometimes when I go through this whole process. Everything looks fantastic, and then the customer reveals to me that this was a development server and there's nobody on the database right now anyways. And I always say, well, we've got some value out of this, but we could have gotten a lot more if we had a real network with a real server with real load. This is important because you may be asked to predict load based on the number of clients that will be accessing an application. So if you are on a, we'll call it a development application in a development server with nobody else on it, if you take those numbers literally and you try to say, well, if one person is X, then 10 person is 10X, no, then you're going to run into a problem, okay? And there's an example of that same script we had earlier, start, the end frame, and now I've put the number of bytes for each step. This was a real test that I did with a customer. We did a query for an account, and it came back with 132,000 bytes. And I turned to the customer and I said, oh, wow, 132K, that's pretty cool. That's lightweight. And they said, no, it's supposed to be like megabytes worth of stuff. And I said, well, usually we're having the opposite conversation. This is pretty good. Well, long story short, we found out in the end that that customer, that account number they had, is their test account, and somebody had deleted most of the data in that record. So this was almost like an invalid test now because it didn't even have what most accounts had in it. So please be careful. This is a great way to validate what you're doing. So let's talk a little bit about trace files and reviewing them. So we're going to analyze each task associated with the application to determine the processing time consumed by the client and each of its dependencies, and we'll talk about that in a few more seconds. Note, if any additional servers, protocols, or nodes are required to complete any task. So you should be aware that this relies on LDAP, this relies on DNS, this relies on whatever to make it work. Okay? You may want to graphically display these results, and I do that a lot now, especially with quote-unquote the cloud. I tell people, I said, now that you've moved everything to cloud, you're relying on a lot of extra stuff that you never had to when it was local, right? So there's an example of our query that I just showed you a moment ago, but graphically. There's my login, there's my query, and so on and so on and so on. And you don't have to have more than this. This is enough. I tell analysts all the time, I don't want to deter you, but face facts. I'm going to say 7 out of 10 times, nobody will ever look at this again. But those 3 out of 10 times that they do, you better make sure you have in there as much as you can possibly think of. So a month from now, a year from now, you'll have something to compare it to. That's all. Okay. Reporting your results. So a sample chart comparing various protocols and applications, copying the same file. And this was an example I did with a client as well. So you can see here it says bits. I don't know how good your resolution is. Bits here on the y-axis, and it's 10 megabits on the top, 1 megabit here on the bottom. And you can see various lines. This is the same client, the same server, the same file, just using different protocols. And people know this just generically, it makes sense, but people don't understand this until they actually see it like that. Okay? Boot up configuration baseline. I hinted at this one earlier. So the goal of this one is to record the behavior of a PC on the wire when it is powered on. I'm stressing on the wire because many times we have laptops that can go Wi-Fi. I tell people just disable Wi-Fi for this test and plug a piece of copper into it just so we can get everything, all right? That way half of it doesn't go out one way and the other way. The client does not need to be present since no login is required. So a lot of companies have their basic, they call it like a PC build or a PC standard or a profile for their standard configuration for their equipment, and that's what we're trying to do is find out when somebody turns that on, how much traffic does it generate. Any dependencies, protocols, and load will be documented. I did a job at a school board.
Uh-oh. We lost Tony.
Oh, that's a shame.
No, he'll be back. He'll be back.
I was enjoying that.
We did that once. We did that once. See, he's back.
He's back.
I don't know why that happens to me. Must be the Canadian thing.
It's okay.
All right.
I checked with your network manager.
Yeah, that's right. My cat is sleeping right now. I'll open a ticket with him later.
Yeah.
Any dependencies, protocols, and load will be documented. So the methodology is important, right? So place the protocol. Oh, yeah, I'm sorry. I was just telling you. I was working at a school board last year, and they turn on their computers, and 80 megabytes of data gets pulled down to the PC just turning it on. Not logging in, just turning it on.
Tony, do you still want to show the PowerPoint? If you do, then you need to do screen share. And while Tony is doing that, I just figured out that the event page looks a lot different for the viewers than it does for the panel members. So for the viewers, if you want to ask questions, look on your upper right corner. There's a few icons. One of that looks like a checkerboard. Click on that and click on Q&A. Okay, Tony.
All right, good. Thanks. So that school board had 80 meg coming down when they turn on their computers, and at the end of the baseline, we found out that every time they turned on their computers, they always got Adobe Acrobat and Microsoft Office installed every single time they turned on their computer, even before they logged in, and that became evident in the baseline. So you uncover lovely little things like that. All right, so the methodology. Place your protocol analyzer either on the same hub as the workstation or configure some form of port monitoring, mirroring, spanning. It's all the same thing. Be careful. If you set up a MAC-based filter, you may miss some packets because some protocols like DHCP replies may be from the DHCP server and the destination will be broadcast. Well, if you pick the customer's MAC, then you're going to be missing those packets. Okay? So just be careful about that. After powering the workstation on, ensure that all the background services are loaded by simply observing the hard drive light. So I'll walk you through this. I turn on my laptop. The other machine's already capturing some packets. I'm watching the machine that I've just turned on. The login screen may appear, but it may not be done. I just eyeball the hard drive light, and I kind of pay attention when it settles down. And hard drives are always kind of doing something, but there's a difference between actively accessing it versus just idly flashing the light, right? So in this example, different baseline example, this is another one I get all my customers to do when I do my on-site training. We go to a folder that's on a network drive and we just search for something. So I did this here in the office. I picked my network drive, I went to a folder called articles, and I simply typed the word Cisco. That's all I did. Okay, and I got tons of, I'm sure you do too, lots of articles that refer to Cisco. So the goal of this exercise was to record which protocols are used and how much traffic is generated. Because that drive, for the people familiar with Microsoft, uses SMB or server message block. Well, server message block can run over a host of different port numbers. So it'd be kind of nice to make sure that if you thought it was quote-unquote the latest one, port 445, then that's what it is, not 138 or whatever, okay? This type of test allows us to understand how remote users may experience this same task which they perform regularly. So I've had this with a bunch of customers, right, where they say searching for stuff takes forever. So this is all I did, right? For the people obviously who know, this is Microsoft's Windows Explorer, and I just typed Cisco up here in the search box, and I just waited for it to do its discovery. So a little bit about my setup. I've got my laptop. I'm searching for articles on my O drive. O stands for Office, and I search for the word Cisco. That's my IP. I'm Wi-Fi. There's an access point, a big old switch, and a server. Okay? Sorry, Tim, no cat. So in this particular example, this is almost exactly what I would include in the application profile, just so people understand what I'm doing and where I am on the network. So sample results. This is a screen capture from Wireshark, from the summary screen. This is not, I didn't even type this out. Okay? So this will tell me the elapsed time, 6 minutes and 43 seconds to search through that drive. This is telling me traffic specifics. How many packets? 741,000 packets. And even if you know nothing about networking, that sounds like a lot, right? You've got the average packets per second. You've got the average packet size, and the bytes and the megabits per second. 11 megabits per second on average for 6 minutes. Sounds like quite a bit of traffic, doesn't it? For a simple search. And then in Wireshark, I went to the I/O graphs, and I simply had two lines here, red and a black, so I can find out, is all the traffic one way, or is it a little bit of both? And in this case, I'm going to say, relatively speaking, it's kind of both ways. And you have a pretty good idea of exactly what's going on doing a simple search. Okay? Now, again, resist the urge to troubleshoot. Just pretend you're a cop. Just take the facts. Get your little notebook out and just the facts, man. Just the facts, man. That kind of thing, okay? You can even look at things like the protocol breakdown. We were talking about this earlier. And there it is, SMB2, Server Message Block version 2. Do you want to make sure that's what you're using? Then that's what you can check, okay? Hey, look, some IPv6 dribbled in, right? And that's because we have a MAC filter, right? And then document any reported issues. And nothing wrong with an opinion as long as you remember that's all it is. And what I mean by that is all these protocol analyzers have expert symptoms and analyzers and telling you what's wrong and what's right with your trace file. And it says right here, this frame is a suspected retransmission, 103 packets. Again, I'm on the same network with my server. I might want to find out where those came from. Okay? Packet slicing. quick note about packet slicing. Since we're not examining the payload of this, we can packet slice. So packet slice means don't save the whole packet, just save a portion of that. In this case, maybe save the first 128 bytes. Slicing the trace file makes this file size much smaller, which allows Wireshark or any other tools to process it much quicker. This will provide all the addressing and enough of the protocol information for this exercise. This is also a good example to packet slice when stuff's encrypted. You can't see the data anyways, or legally, if you're not allowed to see the contents of that payload for legal reasons, again, you might want to slice that out, okay? I don't know of a way to slice this trace file from within Wireshark. I just use the edit cap utility that comes with Wireshark from the command prompt. For the people who care, this is what it looks like. This is a big long string of stuff, and you can see -S means slice, 128 bytes. Okay? Now what that means is this trace file went from being approximately 600 meg to 98 meg. Same trace file. Okay? So it makes life a little bit easier for you. And that's what it looks like in the actual Wireshark detail screen. It says, hey, capture length 128 bytes, but the actual frame was 386. So you know that you don't have the full frame. It even says in the summary here, packet size limited during capture. You see that? So those are all your tips and cues that that's what you've done. All right. So at the end of this exercise, the customer's asking me, so what do you think, Tony? And I said, well, can we use a different protocol other than SMB? You know, can we use HTTP? Can we use any other protocol? Do the results change if we choose a subfolder? So instead of choosing the main folder and searching through everything, if you know you want to search for Cisco and there's a Cisco subfolder, can we just go there and save an extra step? What's that going to cost us, right? That sort of thing. What effect does IPv6 have? I cannot tell you how many times, as you can tell, this is hitting a nerve. This is how many times people have hinted IPv6 will miraculously fix whatever problem we're working on. They don't even know what the problem is, and they're hinting that IPv6 may fix it. So stop it. Thank you. Since this department does this operation often, they might be able to create an app that makes this more efficient, okay? Would remote clients require internet access? I'm sorry. Would remote clients require internet access with significant symmetrical bandwidth? Yes. And that's the other thing people don't think about is if this thing is kind of hot and heavy both ways, consuming a lot of bandwidth, that means when you work from home and you have 10 meg DSL down but 1 meg DSL up, will that affect your performance? Of course it will, right? And there I am. So that's it. So that was our my first kick of the can on baselining. I'm just
Tony, first off, you said something about your about the network not growing. If your network's not growing, you're probably going to be out of a job pretty soon.
Heavy both ways. Yep.
And Tony, we're gonna have more questions for you. But look at who else showed up today. Look at the mystery guest.
Yeah, I saw Paul.
Mr. Paul slipping in there.
I snuck in through the back door.
Awesome.
No, it's not even that. But it's as rare as it is to find Tony at his home. It is rare to find both of you on the same time.
Yep.
It's true.
Very rare.
Yeah. We are, in fact, the same people.
Hey, Tony, I have a guy here that I helped in Atlanta for a while, and he's got a actual paper 3-ring notebook, and you want to ask about what baseline before this occurred or that. He opens the book up. He's got all of his notes. He's got a CD of all the captures, okay? And he can go back, and he said the reason I do that is because, number one, I don't trust my computer to survive.
Yeah, right.
And he says this way I can go back no matter what's happened, no matter what's been burnt down or torn down, I can go back and take a look at what was set up in that. So, you know.
That's awesome.
Yeah, and but you did say the thing about network growing. If your network's not growing, you better look for a job.
It has to grow. You have no choice.
Yeah.
Hey, we do have
still like taps.
We do have a bunch of viewers out there, and I would encourage you to ask questions. Again, I just now, after doing this for about a year, that the event panel looks a lot different to you than it does to us. So to ask questions, you go to the top right-hand corner, and there's an icon that looks like a checkerboard or grid. Click on that, and then the Q&A panel will open up, and just ask questions, or even just say hello. And if you do, I would personally send you one of these.
Oh, can I get one? I want one.
This is the Love My 2 Shockfest luggage tag. Now Tim and I don't travel much, so we use it as a paddle in the bedroom.
Nice.
Yeah. All right.
Nice.
I don't have any more. I've given all mine out. I gave them out
I still have a few.
to
So
college.
and if we write out, we will send it to you from our 2015 batch.
Yeah.
So Paul,
So, Paul,
what do you think?
about the?
Yeah,
I've got my usual few questions.
just a few.
I knew it.
We got time, Paul.
I knew it.
Okay, let's go through these quickly. So the point that Tony made about tracing closest to the client first, absolutely. We call that edge inwards, and as he said, one of the things is it's the best place for you to correlate the trace data with the user's experience.
Right.
The other thing is that as you move deeper into the system, of course, all the volume of data goes up, so you've got so much more to look at. So much better to start at the edge and work inwards. Baselining applications, I think it's a great idea. The only trouble is we've got a customer, for example, that's got 400 business applications and 200 for IT. So you need to tier them and really, probably baseline your most important applications. Tony's mentioned about the difficulty in predicting application performance in different scenarios, and of course we had a session on WAN simulation recently, and I agree with Tony. Doing it in a mathematical way, really difficult. WAN simulation is probably your best bet on that.
Oh, good point.
Challenges in a VM environment, of course, vMotion moves the virtual machines around all over the place, so that can be a bit of a challenge. So when you're documenting, you may have to just say, that there's a possibility that this virtual machine may get moved. I noticed you said mirror instead of span, because you thought you'd get away with it, but then lo and behold, you went and said the word span later. So that was a mistake. MAC address filtering, you picked up on that eventually on broadcast versus multicast. Script, you said, I bet we write a script. We do. We call it a diagnostic capture plan, exactly what you do. Blow by blow, this is how we're going to get the data. On your ping markers, one tip I would add is that if you want to have distinctive ping markers for different points in the process, change the length. So we do ping length 101, ping length 102, ping length 103, and then in a notebook you write ping 101, just before he did the login, ping 102 directly after the login, and so on. So that's
Paul,
a good way
I have one better for you with the ping. There's a neat utility I wrote about called fping, which you may or may not know about, and you can just put whatever you want in the ping, a little message.
Yeah, true enough. The only thing is that we tend to have to just use what's available on the PC. Right. It's difficult to get stuff installed. On the boot up of PCs, that's great that you pointed that out. And what we like to do is we sort of find milestones in the boot up process. So, for example, the first time you see it connect to /srv svc or something like this, one of the things that happen in there, and then if you know how long it takes to get to that point with your baseline, if they then say, oh, it takes ages to boot now, you can compare it to your baseline of all those milestones. So that's something we've used quite often. And at that point, I'll shut up.
That was awesome. Thanks.
That's mine.
And thanks for standing up for TAP for me, Paul. Gotta keep Tony straight, man.
Okay. Yeah, so other than that, well,
Tony,
not other than that one we're talking about, as well as that great presentation, Tony, really good.
That was very good, Tony. Thank you.
That was amazing. That was absolutely amazing. Hey, listen, we should just close it now. Sure. Otherwise, it gets way too long. And then and let people ask questions offline. You could do that on the YouTube page. You could do that on the Love My 2 page. You could do that on the Google Plus page. We will be able to see any of that. Tony, now you had talked about this being just the first of a sort of mini series that you want to do under the WTF heading. And so this is the first of a bunch of stuff that you want to do on baselining. What would you be doing on the next episode, just so that our viewers can kind of look forward to that.
Well, I've actually had some people already contact me about this, and these are, it's funny because I've had a lot of people who've attended my sessions, and they love when I do a baseline, and I also work in a bit about protocol analysis training. So, for example, baseline an FTP application, let's learn about FTP. The baseline a web app, let's learn about HTTP, so on and so on and so on. So I think that's what I'm going to do. The next one we do, I'm going to do an actual walk you through a baseline, and then we'll talk about protocol analysis and learn about the protocol.
Excellent. Look forward to that. I'll probably get an email soon from your wife or when she wants you to be home again, so we could do it.
She's typing right now.
So and our viewers, whether you do that, whether you're watching live or you're watching recorded, you could also just comment and you know kind of give Tony an idea where you want to see as you the next or the one after, you know, next episode, the one after that. It's your community, and that's why we're here, right, Tony?
Yep, I'm waiting for you.
Okay, so with that, I want to thank warmly to Tony for coming on to your own show, and Paul for showing up.
Hey, Paul.
Thanks, Paul, and Tim for surviving one more time. You see, you look better already. You just have to be on LMTV. Okay, this is our life support for you.
Yeah,
it works, right?
Yeah.
Every time you come on, you're more energized than ever.
Yep.
All right, so with that, we bid you goodbye. Tomorrow we have a live demo from one of our sponsors, one of the new sponsor, Security Active. So be sure to tune in. Thank you very much, everyone. See you next week or see you tomorrow. Bye-bye.